Hi everybody, this is the video for lesson 7. In lesson 7, we are solving word problems involving the volume of rectangular prisms with whole number edge lengths. So again, if we're looking at a prism, this is an example of a prism. And when we're talking about edge lengths, we're talking about length, width, and height. And again, that's how we find volume. I want us all to remember volume equals length times width times height. So the lesson 7 Zern lesson introduces us to Jeffrey, who likes to build rectangular planters. So we're going to work with two problems and Jeffrey's planters. So here's problem 1. Jeffrey's first planter is 8 feet long and 2 feet wide. The container is filled with soil to a height of 3 feet in the planter. What is the volume of soil in the planter? Explain your work using a diagram. So the first thing I'm going to do is find my question. What is the volume of soil in the planter? Then I'm going to create my answer statement. The volume of soil in the planter is there we go. Okay, so Jeffrey's building a planter, and it said explain your work using a diagram. So the first thing I'm going to do is I'm going to draw a planter. And again, a planter box is something that you would plant flowers or vegetables in. Okay, so here's my planter box. And I'm going to go back into the problem and see what do I know about Jeffrey's planter box. So I'm going to go back to sentence 1. Jeffrey's first planter is 8 feet long. I know the length. 2 feet wide. I know the width. I'm going to go ahead. I'm going to write those down. I'm also going to note that we're working in feet. So length is 8 feet. Width is 2 feet. I'm going to go back up. The container is filled with soil to a height of 3 feet. So I also know the height. So this is 3 feet. So I have all of the dimensions I need to be able to find my volume. Length times width times height. Length times width times height. So I'm going to write that out over here. Volume equals 8 feet times 2 feet times 3 feet. And then I'm going to solve. So I'm going to look at this multiplication problem and think to myself, what multiplication facts do I know? 8 times 2 is 16. But I don't know 16 times 3. Okay, I'm going to look at it a little differently. I know that 2 times 3 is 6, and I do know 6 times 8. So 6 times 8 is 48, so I know that my volume is 48 feet cubed. We always have to make sure that we put the cubic units. So we just answered our question. What is the volume of soil in the planter? And I could have drawn like this. Because we don't know if the soil is all the way up to the top, right? So this could have been our soil. So we can answer our question. The volume of soil in the planter is 48 feet cubed. All right. So we're going to go and we're going to look at question 2 in our problem. I'm going to move this up a little. Okay. Jeffrey wants to grow some tomatoes in 4 large planters. He wants each planter to have a volume of 320 cubic feet, but he wants them all to be different. Show 4 different ways Jeffrey can make these planters and draw diagrams with the planter's measurements on them. Okay, well, let me see. I need to reread this. Okay, Jeffrey wants to grow some tomatoes in 4 large planters. Okay, and if I look at my picture, I see I have 1, 2, 3, 4. Okay, I get that. He wants each planter to have a volume of 320 cubic feet. Okay, so each planter is going to be volume equals 320 cubic feet. 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 Okay, here's the big thing though. He wants every planter to be different, which means he doesn't want them to look the same. So we need to show 4 different ways Jeffrey can make these planters, and we're going to draw some diagrams with the planter's measurements. So I have to think about 320 and how many different ways I can make 320. So I'm going to use the bottom of my paper. When I think of 320, I know that 10 times 32 equals 320. So I'm going to kind of use these factors and look to how I can make these factors differently in order to solve this problem. So I'm actually going to start by just using 10 times 32. So if I wanted to do a length of 10, a height of 32, so we could do 10 feet by 32 feet. What would, well, that's not a very good planter box drawing. Need to give a width, right? There we go. I drew it on the wrong edge. Okay, there's my planter box, or Jeffrey's planter box, let's say. Okay, so if my length is going to be 10 feet and my height is going to be 32 feet, then I have to think about what could I multiply that by to get to 320. So with this one, we have to think, okay, 32 times 10 is 320. 320 times what number gives us 320? Well, we know that any number times 1 is itself. So we could make the width 1 foot. So that's one example of how we could draw a planter box. Now, I could take my 32 and think of the ways I can make 32. I know that 32 is 8 times 4. So I could draw a planter box like this: length times width times height. So I'm going to do that over here. Length, width, height. And you know, when you draw these, they don't have to be perfect. We're not going for perfection. It's more of a sketch. Okay, so here's planter box B. Length, 10 feet. Width, 8 feet. Height, 4 feet. Now, is Jeffrey actually going to build these? Probably not. So it doesn't really matter if it seems that realistic that he's going to build a 32-foot high planter box. We just want to work with these dimensions. Okay, so we can move, let's move to planter C. So you might also think you know other ways to make 32. And I also know that 32, let's see, I'm going to do it like this, 10 times 32 I know that 32 is the same as 16 times 2, or I could do 2 times 16. I'll do that. 2 times 16. So this could be planter C, 10 feet by 2 feet by 16 feet. So I'm going to draw that. Length with, my height's going to be a little taller on this one. It's actually going to come back here and kind of go in there. All right, so we have 10 feet by 2 feet. So length times width times height. Now, for planter D, I'm going to think about my factors that make 10. 10 times 32. So I know that 10 is 5 times 2, or you can think about it as 2 times 5, and then it would be by 32. Length times width times height. So this would be a small, shorter length, short width, really tall planter box. Okay, length 5 feet, width 2 feet, height 32 feet. Okay, so we have used dimensions to find 320 cubic feet 4 different ways. And really what it breaks down to is really understanding that factors, what two numbers can be multiplied together to make a number. And if you kind of think that way, then you can really break down some different ways that you can make this planter. So I really wanted to make sure that you guys understood that you can access the problem sets if you go to, actually if you just Google, I like to Google. If you Google, let me write it up here. Engage New York, grade 5, module 5, lesson 7, or whatever lesson you're working on, it will pull up the Engage New York website, and then you can click on it, and you do have to navigate it, but it's free. This will pull up the math curriculum. And so I think when you get to this part where it says module 5, it actually has topics. We are currently in topic B. But even if you just went and you clicked on the topics, it would then show you what lessons are included. So if you wanted to go ahead and practice your math skills on the problem set problems, like I'm doing 2 with you, but if I flipped the page, I would see that there's also, you know, there's still more problems to work on. So those are all just some things to think about if you do want some extra practice, then you can definitely go ahead and look up those problem sets. You can print them out. If you have a printer, you can write them down. If you don't have a printer, but you want to be practicing. Okay, so I hope that seeing 2 problems from problem 7 helped with your understanding of solving word problems. There actually isn't a lesson 8 in Zern, so I'm going to readjust your math assignment. So lesson 7 will be your last lesson to complete for this week, and then you'll need to go ahead and complete the topic B quiz. Okay, so please send me a message if you have any questions about lesson 7 or your math home assignments this week. Thanks.